I am in the exercise book on page 102, and you can tell that I've got another one of those wonky scans. When my scanner feeds pages through, it just does all kinds of weird things. So I'm sorry that this is a little bit crooked, but I think we can make it okay. Here is number 4. Which graph represents the function that they've given me? So I'm going to write this function down over here. F of x equals x to the second power plus 2x minus 8. I love this question, and you will too, I think. This tells me that we have a parabola. It's a positive x, so that tells me that it opens toward the sun. It opens up. It's like a flower blooming out. And then this is not baby B, it's baby B's twin brother, it's baby C. So this is giving me the y-intercept. With that knowledge, I think we can find the one we want. So I won't need all of this space for this problem. So we can eliminate option A because this is a flower that's wilting. Its petals are falling down. That's a negative x squared. So let's take that one out of the mix. B could be the answer. We'll leave that one in. C cannot be the answer. It's a flower that's opening to the sun, but it's at positive 8 on the y-axis. So that doesn't match on the basis of the intercept. D is a flower that's wilting, so that can't be the one. And E is a flower that's opening, but it doesn't even touch the y-axis in this picture. It has an x value of positive 8. So just by knowing what a quadratic, how it's made and how it's written in a formula, I can tell you that this answer is B. I really didn't even need a pencil to do that one. I like those. Number 5. Let me crop this off that old wonky page. And this one says, what is the common consecutive difference for the linear function p of x equals 11? This is an interesting one. I think I am also going to graph this one for you. So let me cut that out and see. I'm going to put it on another page. Well, sorry, I got to crop again. There are times that I still don't know what I'm doing on this iPad. It's like all of a sudden it just changes its mind and does whatever it wants to. All right, so we're going to need a common consecutive differences table for this problem. This is a very interesting problem. And I'm debating, I think I'm going to graph it at the end because I want to let you see this as it unfolds here. So let's do a table. And remember, we need to pick some x's in consecutive order. I'm going to pick 5 of them. And I'll just go ahead and mark off a space for those. And I need a column right there. We'll put X and Y in that first chart. I'm going to give myself some room. They told me to do the first consecutive. No, they didn't. But they told me it's linear. So that means it'll be common at the first level. Okay, so here we go. The function is p of x equals 11. All right, so here we go. We have x values and we have y values. So I'm going to pick -2, -1, 0, 1, and 2. And let's test the function. The x's must be different for a function to exist. And it does. Okay, let's substitute. So when we have a value of -2 for our x's, what do we get? 11. When we have a value of -1 for our x's, we get 11. So this is not 1-to-1 for sure, because I've got an 11 twice now. Let's try a 0. So what in the world is going on here? Other than I can't write functions. P of 1 is 11. P of 2 is 11. So what in the world is happening here? When we go to calculate our consecutive differences, we get 0 all the way down. So it is common at the first level. It's definitely linear. It's in a line. So what's happening? Can you picture this graph in your mind? Let's graph it and see what it looks like. Or do I want to do that? I don't want to graph this one. I don't. Let's take a look at our answer choices. What is the common consecutive differences for the linear function p of x equals 11? I do want to graph it after this. Is the common consecutive difference -11? Is it 0? Positive 11 does not exist, or any real number that I could put in there. Don't let it trip you up here. You know the common consecutive difference. It's 0. The question is, at least to me it would be, why? What's different about this graph? Well, here's what it's literally saying. When x, I am going to put it in there. When x is -2, y is 0. When x is -1, I'm really screwing this up. When x is -2, y is 11. When x is -1, y is 11. When x is 0, y is 11. When x is 1, y is 11. When x is 2, y is 11. Now let's graph it. So I'm definitely going to need to go up to 11 for my y. So here we go with the coordinate plane. I don't want red. Okay, so there's red. I'm sorry, x. And here is the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so when x is -2, y is 11. When x is -1, y is 11. When x is 0, y is 11. When x is 1, y is 11. And when x is 2, y is 11. So we do have a linear function. It's just horizontal, if I can draw it correctly. That is the graph of y equals 11. Its slope is 0. It doesn't matter how many times you plug in an x value, the y will be 11. And here's the reason. P of x is 11. Remember, you can substitute y for the function. And there are no x's on the right side of the equation. There's nowhere to plug in the x value. If it had 11x, then we could plug in x values, but there is nowhere to put an x value. All we know is that y is 11. So this one's a little different. This is kind of a unique function to look at. This is a good one to just sort of explore and figure out what's really going on. And I can't move that down without ruining everything, so I won't bother it. But that's a good question. The answer's B. The consecutive 0 there is unmistakable. But the graph on this one is kind of interesting. All right, let's go with number 6. I don't want to do that. I want to crop. And this one gives us tables of values. It says the tables show the second consecutive differences for 4 functions. Which table corresponds to a function that is neither linear nor quadratic? So I'm going to put this one right here just to save some space. Okay, so let's look. This time they've just done the work for us. We don't have to draw the table out. So at the second level, you have common consecutive difference. I'm going to abbreviate that, but let me write it down for you. I'm going to call that CCD. So the CCD is common, it's at second degree. That is a quadratic function. I don't need to see the function to tell you that it's quadratic because it's common at the second level. On this one, at the second level, the CCD is common. So this is quadratic. In other words, this is the column we're looking at. They're just showing it to us across the page instead of up and down like mine. All right, this one, at the second level, it is not common. So it is not quadratic. It's not linear either, because linear would have already been common. So I think this is the answer we're looking for. But let's look at them all. Here I have a common consecutive difference at the second degree. So this is quadratic. And in this one, I have a common consecutive difference at the second degree. So this one is quadratic. The one that is not quadratic and it's not linear is going to be option C.